All right, so for this section, we're actually going to split it up over 2 days. We're going to get into solving systems algebraically, so we're going to look at what's called the substitution method, and then we're going to look at the elimination method. Both methods have certain situations where they're preferred. What I'm going to tell you is that I'm a very big fan of the elimination method. To me, it's a lot faster, straightforward, to the point. But substitution shows up quite a bit on where sometimes it's the faster route. So I really don't care which method you choose, just as long as you're accurate. But be warned, when I'm doing problems on the board and it doesn't explicitly say which method to use, I'm going to use the elimination method every time. So if you chose to do it with the substitution method, don't erase what you did until we get to the answer point, and then if your answers are wrong, then come up and see me and figure out what happened. Everybody all right with that? Yes? Okay, I just want to remind you that there's two methods. All right, so for the substitution method, it's a three-step process. So you might want to write these down. Let me get a bigger eraser. There we go. All right, so step one, you're going to solve one of the equations for one of its variables. So since we're dealing with systems here, we're going to be dealing with multiple equations, right? So you're either going to see x, y, or x and y. All right, so in general, for the substitution method, you have to figure out what x is equal to or what y is equal to. Okay, so you have to solve for one of the two variables. Everybody okay with that? Yes or no? All right, and then because it's called substitution, we have to substitute that statement back into the other expression. So we're going to substitute the expression from step one into the other equation and solve for the variable. So what that means is you're going to have an x and a y, and x and a y, right? Let's say we isolate y here. So we're going to get y equals some statement. So we're going to take that statement and put it back into the second equation, so there's only one variable now, and then we're going to solve for that variable. And I know this is all kind of abstract right now. We're going to run through a couple examples, so that way you can see what it looks like concretely. Okay? So don't worry. Just get this copied down. Because if you don't know if you don't know what the process is supposed to be, it's real easy to get stuck and not know where to go. All right? And then step three, substitute your known value back in and solve, there it is, any remaining variables. Okay? So this process, it's going to be a lot of substitution. It's going to be a lot of plug back in. Okay? So it's really important that while we're working through this, you're taking notes and you're following the steps, because there's a lot of steps. All right? Like I told you yesterday, Chapter 3 is filled with big processes. Any of the processes on their own should not be overpoweringly difficult, but because it takes so long and it has so much work, it's easy for you to get scared because you guys don't have a lot of confidence in your math skills. But believe me, all of you in this room have proven to me that you can handle all of these individual steps, so you just got to have some faith in yourself and step forward. All right, everybody okay with the substitution method, yes or no? As far as the basic steps. All right. All processes, right? It's one thing to describe it, it's another thing to be able to do it. And usually when it comes to math, being able to apply it to a setting, right, actually work through one, get your hands on it, always makes things better, okay? So there is one oddity that I want to talk about. We still have the three solution options, okay? We still can have one solution, we can still have no solutions, and we can still have an infinitely many number of solutions. But because we're not graphing these, the result is going to look a little bit different. So for one solution, that's going to be our regular operation, okay? And what I mean by that is when we isolate and solve for a variable, we're going to get x equals a number, okay? Or y equals a number. So when you have one solution, it's when you get an actual value for each variable during the solving steps of the process. So as you work through the process, your variables don't disappear, they stay. And you can get x equals a number or y equals a number. Everybody okay with that? Yes, no, maybe? Okay. For the no solution and the infinitely many number of solutions, your variables will actually disappear. You'll be working through it, and you'll have to subtract x from both sides, for example, and you'll get the x's to completely go away. That's all right. It can happen. Okay? So don't get scared if you're like, but the x's are gone. That's fine. So when you get the variable to cancel out and the result is not a true statement, so you get something that's false, right, like 5 equals 3, is that true? No. That is what no solutions look like. It doesn't matter what value I put in for x, I will never get the left side to actually be able to equal the right side. Is everybody okay with that? That's what I mean by a false statement, right? So the variables are gone, and you get something that is not true. That's what no solutions is going to look like. If your variables stay and you get a value for each one, that's what one solution looks like, and this is what we're going to encounter the most of. So we've got one solution, no solution, and then the last one here is an infinitely many number of solutions. And for this one, it's when you get the variable to cancel out, okay? So the variable is gone again, but this time the result is a true statement. All right, so we have three options like always, right? If the variables stay, we have one solution. If the variable disappears and we get a false statement, no solutions. If the variables stay, or sorry, if the variable disappears and we get a true statement, infinitely many number of solutions. Everybody okay with that? Yes or no? So it's the same thing as always. We always have three options when it comes to solving a system. So solve the following system algebraically. So we have two equations, right? It does not matter which equation I work with to begin, okay? First of all, how many variables do we have in the first equation? 2. How many variables in the second equation? 2. So it seems that we have the same number of variables. There's no shortcut here, right? It seems that I have to isolate a variable. If the statement only has one variable, that'll be easier to work with than something that has two variables. So for us, which equation do you want me to work with? The top or the bottom? Bottom? Okay. So I'm going to take this one to start. Now, I have to isolate one of the variables. Doesn't matter which one. No. So which variable do you think would be easier for me to isolate up here, x or y? X, because there's no coefficient on it, right? So how do you get x by itself? Subtract 4y. Oh, yeah, you meant move y? Yeah. Okay, so everybody okay with x being isolated now? Okay, now remember, I can only solve for one variable at a time. So as long as this equation has two variables, I'm kind of stuck, right? But if x is equal to negative 4y minus 2, what do you think I can do with this statement now? I can plug it back into the other equation, the one I haven't used yet. So I'm going to take my x, and I'm going to substitute in the statement from the right side. Pardon? Oh, shoot. Yes, thank you. That's a +2. So now if you notice, what's the only variable I have in that equation? I only have y. So now what do you think I'm going to do? Solve for y. Okay? So I'm going to distribute the 2, get rid of parentheses first. Okay? On the left side, is there anything that can group up? Is there anything that has same variable, same power? The y's. So what's negative 8y plus 5y? Negative 3y. And how do I get y by itself? Minus the 4. And then divide by, not 3, but negative 3, right? So what's 3 divided by negative 3? Negative 1. So y equals a negative 1. So now I have the y coordinate to my solution. Any questions on how I did that? Yes or no? Okay, so now I have to find the x coordinate that goes with it. So what I do is I take this y and I plug it back into either of my original equations. It does not matter which one. Okay? I'm going to use the second one just because it's already over here. So I'm going to take this equation and plug in the value that I know, which is that y is equal to negative 1. Everybody okay with that? Yes or no? So now, what is the one variable I have? I have x, right? So that is the variable that I am going to solve for. So x equals 6. Everybody okay? Yes, no, maybe so? I don't know. Okay, so my final solution, remember you have to write your solution as an ordered pair, right? So what's the x-coordinate to my solution? 6, and what's the y-coordinate? So I'm saying that this is the place where if I plugged in this value for x and this value for y, this would be true. And if I plugged in this value for x here and this value for y here, this statement will also be true. All right, and you can check that real quick, right? 12 minus 5 is 7. 6 minus 4 is 2. So this x and y, when I plug them in, I get a true statement on the left and a true statement on the right, which means that this is, in fact, the solution to my system. So this is your process. Step 1, pick one of your equations, isolate one of the variables in that equation. Okay, that's step 1. Step 2, take this answer, plug it back into the other equation using substitution, So you only have a single variable in your statement. All right, step 3, solve for that equation, and I guess there's actually going to be a step 4. Back substitute this result into one of the other equations in order to find the other coordinate. Like here I isolated x, right? I could isolate y. And then I would get x first over here, and then plug it back in, and I get the exact same coordinates. Or, like you were saying, I could start with this equation, isolate x, or I could start with this equation and isolate y. It really doesn't matter. If you do all the math right, you'll get the exact same answer because there's only one place where these two lines will coexist. So however you go about getting there is entirely up to you. So if you're up here going, oh my gosh, there's too many options, then pick something and stick with it. Okay, for me, I tend to usually pick the first equation is the one that I'm going to substitute with, and I always get y by itself because that's what we do the most of. That's just me. That's my style. You don't have to copy it, but if you develop something like that, then when you see solve by substitution, your brain goes, okay, take this one, do this. Okay, everybody all right with that? Because if you don't have it, if you have too many options, your brain will get scared, especially on like the ACT. Okay, so it's more important that you have a system that you can trust than you do what I do.
Yeah, I'm feeling it.
Everybody good with that? What? This one, dude, if they put this on the test, this is super easy to solve without doing any real math. First of all, the ACT is not a math test at all, so don't let anybody make you believe otherwise. It's pick the right answer if I give you a problem. That's the test. So if they said solve the system, I would never solve the system this way. They give you the 4 possible answers, right? Plug them in. Which one does it work for both? Well, I can go 2 times 6 is 12, minus 1 times 5 is negative 5, 12 minus 5 is 7. That checks. 6, 4 times negative 1 is negative 4. 6 take away 4 is 2. Oh, hey, 6, 1, negative 1 is my answer. Done, moving on. If it doesn't work for both parts of the system, it can't work for the total answer, so just check it.
So you just do math back.
Yeah. If you don't know how to do the math forward, then take the answer because they give you the answers, plug them in, and see which ones work. One of those 4 has got to be right. They're not testing your ability to go from the problem to the answer. They're testing your ability to pick the right answer if I give you 4 options. So all of the test-taking strategies that we've given you throughout the years, use. It's not a math test. It's a pick the right answer. So what I mean by that is if you're picking C, you have to pick nothing but C. If you alternate, you actually cut your chances in half. So if you're like B, C, B, C, that went from 34 and 33 to 16 and 15. Okay, or sorry, 17 and 16. So if you're going to do that, because remember, a blank answer is a wrong answer on the ACT. So when like time's up and you're like, I got 10 left, pick one of them. It doesn't matter which, either B or C, and just run that value. Okay? So back to the math. If I want you to solve this system using substitution, which equation do you want me to work with, top or bottom? Bottom, okay. So this is step 1, right? Step 1. We're going to take the bottom equation just because, right? Which variable do you want me to isolate, x or y? Okay, y. So does it matter? No. So if you want to do x because it's only one step, go ahead. You should get the exact same answers we do up here, okay? So how would you get y by itself? Okay, so there's step 1 done. Everybody okay with step 1, yes or no? Any questions on step 1? Okay, step 2, what do I do with this result?
Put it in for 2x plus 5y.
Right, perfect. Put it in, substitute it in for the other equation, right? So I'm going to take 2x plus 5y equals negative 5, so this is step 2. And I replace my y with what I got over here. So I'm saying that y is equal to 1 minus x over 3. Okay, so I take my y and replace it with that piece. And now, what's the only variable I have over here? X, right? So I'm going to solve for x. So 2x plus 5 minus 5x over 3 because you have to distribute. I have 2 x's, right? I need common denominators. Common denominator between 1 and 3 is 3, so this is going to become a 6 over 3. So 6 take away 5 is going to be x over 3 plus 5 equals negative 5. How do I get x by itself. Minus 5, so you get x over 3 equals negative 10. And then multiply by 3, so x equals negative 30. Any major questions?
Is that a 2?
Yeah, it was a 2, but because I need the common denominator, right, I have to change, because this is 2 over 1. So if I multiply the bottom by 3 to get the common denominator, I have to multiply the top by 3 and get 6. And real quick, what's 6 divided by 3? 2, which is what I started with, right? So you can always check those if you're not sure. So 6 over 3 minus 5x over 3 is going to be 1x over 3 positive. You get your plus 5 still. Subtract that from both sides to get x over 3 equals negative 10. Multiply by 3, and you'll get x equals negative 30. Everybody okay? So there's part 2 done. Okay, now step 3. Now real quick, which variable do I already know? X. Which variable am I trying to find? Okay, do I already have a situation where y is isolated? So you can go all the way back to the original, or you can just use this other equation that you've already found. The only danger with this is if you made a mistake here, you're going to compound the mistake. But if you made a mistake here, this answer is going to be off anyway, so it really won't hurt you. Everybody okay with what I'm saying? So if you want to, you can go back to the original, or you can use the one that you've already taken care of. So if I use this one, my x is negative 30 all over 3. So what happens to the double negative becomes a what? And what's 30 divided by 3? And what's 1 plus 10? So what is my final solution here? So solution is going to be the point negative 30, 11. So you still have to write out your solution as an ordered pair. It has to be a point. Everybody okay with that? And let me check to make sure that works. Negative 60 plus 55 is negative 5, and negative 30 plus 33 is 3. Yep. Any major holy snots, or is it just that you feel like you need to work with it some? Yeah, it's kind of like a piece of metal right now, right? I've shown you how to hammer it, but until you start swinging the hammer, you're not going to really know. But is everybody okay with the 3-step approach, though? Oh, what's negative 30 times 2? Negative 65 times 11. 55, right? What's negative 60 plus 55? Negative 5, right? Okay. Negative 30 plus 3 times 11 is 33. What's negative 30 plus 33? Okay, and you should be doing that. They're not going to tell you check your solution, but you should be checking your solution. All right? What have I told you from the very beginning? I don't care about speed. What is it that I care about? Accuracy. If you're wrong but quick, it doesn't help you. If you're right but slow, we can try to gain speed. Okay? Just like if you're running the 100-yard dash or the 100-meter dash and you're the fastest guy out there, but you're running the wrong direction, is it going to help you? No. Accuracy above all else. So don't worry about speed. Don't worry about time right now. Get to where you can get the right answers, and then we'll look at ways of gaining speed. Everybody okay with that? So you should be checking your solutions manually to make sure that this is, in fact, the solution to the system. If it's not, then you got to go back and check where your mistake is. And what I'll tell you is the majority of the mistakes you're going to encounter, plus and minus signs. You guys have this really nasty habit of just ignoring them. Like, oh, I don't need that negative from line 2 to line 3. Yeah, you do. Well, I had that negative in line 4, but line 5 doesn't need it. Yes, it does. Okay? So be careful, slow, accurate, meticulous. All right? This is the time where, once again, devil is actually in the details. Move slow and move right. Everybody okay? Yep. All right. So your first shot from this chapter or section is just 3 through 14. So I want you to take a look at those 12 problems tonight. And what I'm going to tell you is that we're going to do this in 2 chunks, right?